Hello, hello? Hello. Alright, let's see if this... Hello? It's actually working this time. Hello? Alright, let's see if this... Oh my gosh, it is. Hell yes. Let me, go and close that stream. Holy shit, I actually have my work working this time. Yay! So, yeah. Here we go. Stream part 2. Let me close my door real quick. Alright. There we have it. Anyone wondering what happened last stream, if any of you were there last stream, which is the 1 or 2 people in my chat right now. So my first stream, my debut stream, quote unquote, it was 3 hours of me talking, followed up immediately at the end of my stream by me finding out the fact that my stream was not picking up my microphone at all that entire time. Luckily, however, let me see, what's that? Yeah, luckily my my recording of the stream picked everything up. So I managed to upload the VOD to my YouTube channel, and everything looks good over there after a little bit of editing. So yeah, it turns out streaming and by extension uploading videos does not particularly play super well when you have multiple audio tracks. So I managed to fix it. My audio tracks are set up properly this time around, and you know, hopefully they should be a bit smoother this time. And before I get started, I'm actually going to turn on my fan over here, get that running, so I don't get too hot during this. Alright, there we go. So, my fan's running now. I don't think you should hear it. Maybe we should be good on that front. I see there's one person in my chat, but I think that might just be me watching my stream. I don't know. I still don't know how that works. That being said, I'm going to check my actual YouTube, make sure that stream's running too. It should be. Yep, live. Hell yeah. Alright. 1 second while I finish the setup. Sorry, I started streaming a little late today because I was working. I ended up making it home a little later than I was expecting to. So, and then I had to tie my tie, so that's what a lot of this start streaming soon was, me getting that working properly. But hey, you live and learn. You learn from your mistakes, and that's exactly what happened with last stream. Is I made a big ass mistake, but it worked out because now I know how to fix that one issue, so I don't have that issue in the future. Or if I do have that issue in the future for whatever reason, then I know how to fix it. Thank goodness for recording software, working the way you need it to. All right. Headphones are really won't fall into my ears. Let's see. Sure, everything is golden. Alright. Alright, hello. We're here. We're live. Let's go. Alright. And you, that was the wrong, whoops. Hold on. Monitor, that's what it is. Okay. Yeah. Any of you that were here last stream, you know we're working on this shit. Well, I assume you know that's what we were doing because you couldn't hear the entire stream, but let's just say hypothetically you knew that that's what was doing, well, we're about to continue it. You're gonna continue this until I finish this, and I'm gonna try and figure some other stuff out. I'm gonna mute real quick. I need to put my clothes on. I forgot to do that. Perfect, just like that. Alright. Get my headphones to stay in, we can see where we left off. Once we do this, I'm gonna I thought I unmuted my mic, but I accidentally clicked, did not click on that. I'm glad I checked that. Shit. Sorry. Trying to figure this out. Wait a sec. Yeah, for loops. All right, we're starting here. So lost the. Don't know how many times we should. Okay, start from the top. Yeah. Start from the top. And the last. Actually, hold on. That thing felt weird. I didn't know why. My fucking light isn't on. Oh my lord. Alright. The last lesson we looked at while loops. We found they were useful if we don't know how many times we should record. How many times we should repeat code. However, they could result in infinite loops if we're not careful. The loop below never ends because we never increment number. Yeah. The safer and easier kind of loop, the for loop. We'll look at it in this lesson. Unlike while loops, for loops don't run infinitely, so it's much less likely that you'll get bugs in your game. We recommend favoring for loops over while loops because of this. Let's change the code above to use a for loop instead. Loop below will change the cell 30 times. Okay, so for number in range 3, cell plus equal vector 2. The range, okay. I've never understood this in range function or how it works. Godot has a help. Let's explain what's going on here. Godot has the helper function range, calling range in creates a list of numbers from 0 to n minus 1. So calling range 3 outputs the list of numbers 0, 1, 2, and range 5 outputs 0, 1, 2, 3, 4 because it starts at 0. Yeah. One list of numbers would range 6 create 0 through 5. Yeah. It's weird that some of these actually start at 1 if I'm remembering correctly. I don't know for sure, but I think so. The function range in creates a list of numbers from 0. Oh yeah, I already read this. 5. Okay. How for loops work. In a for loop, the computer takes each value inside a list, stores it in a temporary variable, and executes the code in the loop once per value. So 3, 2, right number, okay. For loop, in a how for loops work. In a for loop, here takes each value inside a list, stores it temporary variable. It's just, I think I already read that. Off my game today for some reason. In the above example, for each item in the list, 0, 1, 2, Godot sets number to the item and executes the code in the for loop. We'll explain arrays more thoroughly in the next lesson, but notice that number is just a temporary variable. You create it when defining the loop, and the loop takes care of changing its value. So you can name this variable anything you want. Okay, so just setting up temporary stuff, I guess. Scope behaves the same as the previous example. So I do. So 0, 1, 2. Okay, so that's what this means, I think. The range of 3, ranging from 0 to those 3 numbers. Pretty much what it's saying, I guess. I think, I don't know. Previous example. Yeah. Both examples, we print the value of the temporary variable we created. number in the first example, an element in the second. Xedo moves through the loop and assigns each value of the array to that variable. First it sets the variable to 0, then to 1, and then finally to 2. We can break down the instructions. The loop runs. Okay. First the loop runs. You can see how a loop is a shortcut to code that otherwise gets very long. So function run. What was that? What was that? Hold on a second. I swear I saw something fall. Be right back when I get my headphones back in. I'll be right back. There we go, everything should be fixed now. Let's see here. I can't actually see myself, hold on. I can't actually see. Okay, yeah, that looks fine. It was good enough at least. Okay. So that should be running. Alright, sick. Damn it. That microphone. There we go. Good lord. This thing's a nightmare to keep up, right? Okay. Back to what... Looking over there. Back to what we were doing. This. Man, today's stream has been crazy. Instructions. Okay. Sudo moves to the loops, assigns each value the array to that variable. First, it sets the variable to 0, then 1, and finally 2. We break down these instructions, the loop runs. You can see how a loop is a shortcut to code that otherwise gets very long. Okay, let's see. Try to step by step. Zero. Okay. Okay. We can put whatever code we like in the loops code block, including the other functions, other function calls like draw rectangle. Okay. Using a for loop instead of a while loop. Here's our old move to end function, which used a while loop function, move to end, while cell.x is less than board size x minus 1. Cell minus x plus equal to 1. Okay. We use a for loop instead. Function move to end. For number range board size x minus 1. Cell.x plus and equal to 1. Okay. Finally, constantly checking if the robot reached the end of the board with the for loop. We take the board's width beforehand, then move the robot a set amount of times. So, okay. That did nothing. Okay. Sorry, I was looking at my chat. Let's see. Are they constantly checking? Yeah, if the robot. Those are still works the same because. Okay. Yeah, bam. This makes it a little bit wide. 9. The practices, we'll use the for loop in different ways to get you used to this. Great. So for loop to move the end of the board. Once again, the robot has decided to stand at the top of the board. This time, use a for loop in the move to bottom function to have it move to the bottom of the board. Board size is determined by the vector2 variable board size. Okay, so I should go back. What the fuck? Read to this notion. Do forward. Completely forgot how to do this. Let's see. Okay. So yeah, I feel this is wrong. 0, you wrote something that is okay, let's see. Still the X. Yeah, that's completely wrong. What the fuck am I doing? Oh, I think I ripped what the call. Wait, what is this? I just not have a indentation, I think. Oh, that's, hold on. Jesus Christ. What? Why is your code of specific type? But I thought. Oh. Oh, I needed to do a .x specifically, that's right. No, it just disappeared. What the fuck? Alright, fuck it, I'm just gonna hit solution. Who? Number. This vector shit is gonna be the fucking death of me. Good lord. Okay. Let's just time to send ourselves again. Number in. Oh, range. That's right, range was the thing. No, it'd be the port size, that's right. Size -1. Nice one. cell. Let's equal. Alright. Wait. Let's just do the y value. Yay, I did it. Pretty sure that worked as intended. Alright. Draw rectangle. Okay. For numbers in range 3. I think that's right. Huh? Oh. I'll try it. Hell yeah, I actually got that one right. Alright. Alright. The range function we saw in the previous assignment outputs. This range function is gonna be so much during this. So the previous lesson outputs a list of numbers. For example, calling range 3 produces the list of numbers 0, 1, 2. A list of values, numbers, or otherwise has a precise name and code. We call it an array. So we can say calling the range function, which is an array of numbers. You can really write and use that array inside of a for loop instead of the range function. You can run the next function step by step to see how it works. Okay. As you can see, this code still works the same. This that when we create a for loop, we also create a local variable to which the loop assigns one. Yeah, okay. Assigns one value per iteration. Above, we named it number because the array loop over contains 3 numbers, 0, 1, and 2. So we can name it anything we like. We unwrap the for loop above, we get the following code with the exact same behavior. Let's see. Element. Okay. I gotcha. Syntax arrays. They're arrays this way in script. Value 1, value 2. You start with an open square bracket, then you write comma separated values that compose the array. Finally, Need a closing square bracket to complete the array. Here are a couple of valid arrays. Notice how you can mix values. How they don't need to follow one another. Okay. Okay, yeah, I get it. Because arrays themselves are a value type, just like numbers are vector 2, you can assign arrays to variables to reassess them later. That'll come in handy in the next lesson when it uses variables and loops. It's like a list, pretty much. First, let's see when you use an array. Okay. Variable equal to we use arrays in computer programming. We use arrays all the time. Precisely, you'll use them whenever you just store a list of things. You always need lists of things in games. The player's party in an RPG, the items in the player's inventory, the high scores in an arcade game, objects in the game world. All of those, many more rely on the limits. Arrays to follow a path. Let's look at a widespread use of arrays in games. Finding and following a path. Games, you need allies or monsters to find their way to their target, whether it's the player or some point of interest. To achieve that, we use pathfinding algorithms. As the name suggests, those algorithms find the path between 2 points and allow AIs to traverse the game. It allows, alright. Because those algorithms use arrays of vector 2 coordinates to represent the path to this turtle pet. It wants to follow the robot, but there are rocks in the way. How can we tell it where to walk to reach the robot with an array? So 2, 1, 2, 2, 3, 2, 4, 2. Okay. Every value in the array is a vector 2 and represents a cell the turtle needs to walk through. All the values in the array represent a path draw. In lessons, you see how we can use arrays to store player inventories or design attack combos. Now let's practice creating arrays. Alright, welcome to the robots. Turtle wants to meet the robot, but it cannot find it on its own. Fill the turtle path array with vector 2 coordinates, beginning where the turtle should move to avoid the obstacles and arrive safely to the robot. Okay. Turtle can move up, down, left, or right. It cannot move diagonally. We might copying and pasting to fill the array with a comma separated vector 2 values quickly. Alright. Wouldn't make anyone yawn with that one. Oh wait, oh, I get it. Wait, do I get it? Hold on. I put the parentheses inside, or is it? Yeah, let's go back. Okay, yeah, the parentheses inside. That makes sense. I didn't know if I had to do an entire other bracket or what. Oh. Did you do a comma between these, or is it just a space? Yeah, it's a comma between them. Okay. So if I do vector 2, so I just need to do 2, 3, 4, 5. 6, 7. Okay, so it should be 1, 0, 1, 1. 2, 1, 3, 1, 4, 1, 5, 1. Oh wait, no. Oh yeah, that's right. Oh shit. Okay, so I'm missing one. 5, 2. And this will be 5, 3. Yay! I'm very curious. What happens if I just do 5, 3? Okay. That's what that word means. Okay. In this tactical game, the player or computer can select multiple units at once. You need to call the select units function and pass it an array of vector 2 coordinates to know which units to select. Each vector 2 in the array represents a cell within a unit. You pass arrays in function calls as arguments. As an array is a value type the computer recognizes, you can pass the whole array as a single function argument. Select all units on the board by passing the correct array to the select units function. Just want me to I don't know, I'm gonna put vector 2 at the start of these. See what that does. On it for me. Nope. 1 0. Run. Yep, okay, I just needed me to type in the vector 2 thing. Got it. Use the range function in combination with for loops. The range function produces an array that the for keyword could loop over. You can give for loops any array, they loop over them just the same. Instead of using the range function, we could manually write the numbers and get the same result. I assume people would rather not do that, but for each element inside the array, the for loop extracts it, stores it in the temporary variable number, executes the loop code once. Inside the loop, you can access the number variable, which changes on each iteration. Code works regardless of the array or where you store it. Often you will store arrays and variables for easy access. Yeah. Here. Well, let's go do numbers. Should be 0, 1, 2, I think. For each examples, we store the array in the numbers variable. The numbers variable in our for loop allows the computer to access the array numbers like 4. We have 3 numbers in the array 0, 1, 2. The loop extracts each of them sequentially and assigns it to the number temporary variable. As the loop processes each number, the output will print 0, then 1, then 2, each on separate lines. With the turtle walk, we'll loop. Got it. So I'll click eventually, I swear. In the previous lesson, you made a turtle walking along a path, writing vector 2 coordinates in an array. It's a for loop that makes the turtle walk along the beach. Along the path, sorry. The loop works like this. For each coordinate in the array, it moves the turtle once to that cell. To cell. The same principle unit selection. For each coordinate in the array and selected units, we check there is a unit in that cell. So if so, we select it. In that case, we use an array, a loop, and a condition together. Units, cells. This is confusing at all, I swear. Cell and cell, if cell in the units. Units dot append cell update. Okay. Alright. I'll pretend like I know what it's talking about and move on. These are several features. I have to figure this out before I do what I need to do, but damn. select unit cells or cell in cells if cell in units and cells. Like, what the fuck? Gobo uses several features you haven't learned yet. Okay, that would probably help explain why I'm going fucking nuts over this. Condition. The in keyword allows you to check if a value exists in an array. The array's append function appends a new value at the end of the array. Notice leads to a period after the selected units variable. Where was I? Where did I finish reading? Selected period after the selected units variable to call the append function because the function exists only on arrays. Okay. When functions exist only on a specific value type, you write a dot after the value to call the function to it. Okay. I think I got that. We'll revisit those two features again in the following lessons. The beauty of loops is that they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 units to select. It's all accomplished with only a couple of lines of code. That's the power of computer programming. In the following practices, you'll use arrays combined with for loops to achieve similar results. Okay. AI pathfinding algorithm provided a path for the robot to make to the right edge of the grid. The task is to use a for loop to make the robot move. To move the robot, call its move to function like so. Robot.move2. Move2 function only exists on a robot, which is why you need to access it this way. Okay, so I guess it's robot.move2. And then I put robot path probably. Let's see if that works. Fuck. Yeah? Let's do it again. Yeah. Okay. What the fuck? Oh, that's right, it's 4. Hit this again. Nope, didn't do a damn thing. Okay. Fuck. Well. Okay. What do you mean sell? We weren't using this anymore. We haven't been using this for a while. Oh fuck my lord. Didn't even mention it at all. I don't think that's an actual value in the fucking program. That's why I'm like fucking confused about this. Usually the only time we need it is when it's mentioned that that's a thing you could use. So fucking weird. Why did it not work? Didn't I just do it? What the fuck? What did I do differently? Oh, it's just... Okay. Wait, let me try this. No. What the fuck are you talking about? Oh. Oh, it's not in the range. Okay. What the fuck? Alright, let me go back. What the fuck did I miss? Okay. Okay. Okay, alright. So, and just means, okay, range is a number thing. In an array means just what's inside of it, not necessarily. Range is more so for numbers. Like 0, 1, 2, 3 in sequence, not like an actual list of things. Okay, I think I understand that right. I think. Blah. Okay, let's try this out. Draw many rectangles, something's common in games, however, writing this code by hand can get tedious. Instead, you store the size of your shapes in arrays and use a loop to draw them all in batches. That's what you'll do in this practice. Use a for loop to draw every rectangle in the rectangle sizes array with the draw rectangle function. Draw. They should overlap or cross each other. What the shop function? Fucking shop fucking 500. Try that. Fuck is happening? Each value in the rectangle sizes array is equal to 2. You'll need to access X in it. Why so composed to draw rectangles? Okay. Fucking nothing happened. You drew -1 polygons apparently. The fuck do you mean? Okay. In the loop, you first need to draw a rectangle. Okay. And then jump, otherwise at least 2 rectangles will overlap. That's exactly what I did. The argument when just be large enough to space all the rectangles, for example 300 0. Okay. That's great. Just give it the fucking solution. What do you mean size X and size Y? Where the fuck did that come from? I guess blah X and blah Y. Why is it not using this? Or what in this? I'm so confused. Like I thought it was supposed to be using this. I thought this was just a filler thing that you use in here. What was it supposed to grab? Oh, I think I remember. Still a little confused, but fuck. Alright. Whatever, run it. We'll deal with that later. Figure it out later, okay? I guess technically this should work. Technically true. Don't think this is gonna work though, so. Nope, technically don't overlap apparently according to this program. But ooh, if I go a little lower. Yeah, no, that is too far. Wait, absolute fucking mess of the thing, huh? Alright, whatever. We'll figure these things out in practice later. How many more of these do we have? 7. Okay. 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 Yeah, this course we mostly stored numbers and variables. Store a player's name. There are strings up. Strings are instrumental games and applications. We use them to display information such as descriptions, spell, and the name of a character. What are strings? A string is a value type which holds text. To create a string, you write text wrapped in quotation marks. Quote, quote, for example, this is a string, a text string. The quotation marks differentiate strings from other value types and function names. Remember, we've used strings before in previous lessons. Okay. Yeah. For the hood, strings are arrays of characters. In fact, we use a for loop to loop through the characters of a string as we would with any other array. Okay, so that gets us... Oh. So that's an array too, sort of. Which of these are strings that apply? There are strings one that contains a character and doesn't with the number 1. Name is made up of 4 different characters. Why we use strings? Every piece of text you see in this app is a string that Godot is displaying for us. Much like how vector 2 variables make calculations easier, string variables come with many helper functions and tricks we can use. We can use arrays to store strings too. They're useful for chaining animations. In this example, the playing animation is a specific animation. Okay. I'll figure out how this works better, ever since I got this example given to me. Now I understand this a bit more. Next few practices will use strings in combination with different concepts from earlier lessons. Oh dear lord. The robot has a number stored in the robot name variable. Okay. Change the robot name variable says string instead. So you can give it any name you like. Don't tell me that. I'm gonna do something that's gonna get me banned. Alright. Ban evasion, hooray. Alright, there we go. Let's see here. This practice will chain together animations using an array of strings. You might find such combination in fighting games. Roa has the following animation names: jab, a quick punch, uppercut. The robot uses a powerful jumping punch. Complete the combo array with animation names as strings. And for each action in the array, call the play animation function to play them. Okay, let me go ahead and do this. For number in combo. Should be play animation combo. I think it's clicking. Holy shit, I think it's clicking, baby. Jab. This works. Shit. What? Oh, that's right. How bad this is. These are not variables, they are strings. Yay. Fuck. My bad. Alright, now let's try it. What the fuck? Oh, wait, hold on. Hell yeah. Yeah, I caught that one. That was my fault. Oh yeah. You did it. I actually managed to do that. Fuck yeah. Proud of myself. Alright. So instructions you give. Instructions you give a name and you can call anytime. So that functions can make calculations and return new values. Examples to see why it's useful. Built-in functions that return a value. Integer script make calculations and return a value. The round function. Yeah. For example, the round function takes a decimal number as an argument and gives you back a new number rounded to the nearest digit. 3. Ta-da! Imagine you have a game where you track the player's health as a percentage, the decimal number going from 0 to 100. When displaying the health on the interface, you don't want to show the decimal part. In that case, you may use the round function like so. There you go. Notice how we assign the result of the function call to variable, because the round function returns a new value. We need to either store the result or use the value immediately. Above we assigned it to a variable, but you could also do the following. Set text round health. Okay. Let me take the story a little more. Yeah, okay, yeah, that's perfect. You can assign the return value of a function. I don't know, let me just have to fidget with. I mean, good for my psyche. You can assign the return value of a function call if you plan on using it more than once. Assign the return value of a function call if you plan on using it more than once. Oh. Like, we'll figure this out. For example of LERP. Hooray, LERP. The LERP function, short for linear interpolate, calculates and returns a weighted average between two values. It takes three arguments, the two values to average, and a value between 0.0 and 1.0 to skew the result. In game programming, it's used to animate things moving forward, moving towards a target with a single line of code. Process delta position, LERP position, get local mouse position. And then that moves faster if it's further away, like it's closer, it gets slow. I think, pretty much. Two times delta, so that's right, using the delta function, so I can do that two times, I believe, so it can do it in seconds, I believe. I don't remember fully what was from the original one, but you know, every frame the code calculates a position somewhere between the turtle and the mouse cursor. LERP function takes care of everything. Not the most robust approach for smooth movement, as you learn in the future, but it's a helpful function nonetheless. Writing a function that returns a value. You can make your functions return values. To make a function return a value, you use the return keyword. I just sure everything was still fine over here. A little paranoid after what was happening earlier today. And yesterday too. To make a function return a value, you use the return keyword followed by the value in question. In previous lessons, we had characters working on grids, and for those practices, you are working directly with cell coordinates. Well, cell coordinates don't correspond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell's coordinates to a position on the screen in pixels. Yeah. Just use a function. The function does two things. First, it multiplies the cell coordinates by the cell size, which gives us the position of the cell's top left corner on the screen in pixels. Then we add half the cell size to get the center of the cell. The function returns the result, allowing us to store it in a variable. Cell times cell size plus cell size. That's not right. Yeah. 120. Oh, no, so. Divided by 2? Oh, plus. Then divide by 2. Okay. That'd be, okay, so I'm trying to figure this one out. Or how they did it, rather. So cell size. Don't entirely know how it works, but it's whatever. We'll figure it out later. I'll figure it out later. So, return keyword returns the value. Calling the code, calling the function. Receive the result you call the function. Okay. Some functions return value and some do not. In practices, you can learn which functions return a value using the documentation panel. It will display if the practice requires a display if the practice requires using specific functions or variables. There are functions that start with the term void do not return a value. Other terms means any other term means the function does return a value. You'll learn more about what other terms mean a couple of lessons when we explore value types. For now, let's practice returning values functions. Find a function that converts a position on a grid to the screen. Oh hell. Function takes a vector 2 cell coordinate as an argument. It should return the corresponding vector 2 screen coordinates at the end of the cell. Alrighty then. I literally just did that one from memory. Okay, let's see what this actually means. The cell size is 8080, and then that's 160. Well, then we divide that by 2. 160, that'd be 8080 again. Wait, no. Just multiply, divide, then add. So it'd be times. I don't know what cell is. Is square. Every cell is a square of multiply the cell by its value. Top left or yeah, I don't know. I don't understand that one. Yeah, I'm lost. I'll figure it out some other time. Appending and popping values from arrays. In previous lesson, you learned how to. That is a ladybug that just landed on my screen. Awesome. Create arrays. Start a list of values and how to loop over them. Nice, but you won't go far with that. Only that. The real strength of arrays is that you can add and remove values from them at any time. Allows you to queue or stack data. Okay, now let's take another example. Tracking orders in a restaurant management game. You're making a restaurant management game where customers place orders and you need to handle them as they come. In this game, customers order meals that end up in a queue. You need to prepare them in the kitchen. In this example, we simulate orders arriving and getting completed over time. Over the word. Okay. How do you keep track of pending? Okay, just I'll do this. So I really want their tomato soup, apparently. Okay, enough of that. How do you keep track of pending and completed orders? With an array. When a customer purchases a meal, you want to append it to the array. Then as you complete a meal in the kitchen and serve it, you want to remove it from the array. You do that with the append and pop front functions of the array, respectively. Gotta read the code below before moving on. Don't worry if not everything makes sense. Let's break it all down. Orders. Orders. Add. Order, meal name, waiting orders, and meal name. Okay. Function complete current order. variable first order equals waiting underscore orders dot pop front. Completed orders dot append first order. So waiting orders. Okay, so that just makes it to where all the completed orders are moved to the completed orders tab. Okay. That's how we call some functions by writing a dot after a variable name. Okay, build name is added somewhere else. Okay, I was wondering about this because it's not usually anywhere, but it's if it's somewhere else in here, it'll be like, oh, build name, this equals this, and then this will utilize that. So whatever it ends up being, it'll take that. So, got it. Notice how we call some functions by writing a dot after a variable name, like a given value type has subvariables. It also have its own functions. Functions like append and pop front only exist on arrays. That's why to call them, we need to access it from the array using the .array.append. Let's write down the code. View orders in the waiting orders array by appending them to the array. View orders and the waiting orders are appending them to the array. So, yeah, you can use the add order. Oh yeah, we use the string to represent a meal when calling the add order function. Yeah, that's what I was saying earlier. Completing an order, remove it from the waiting order array by calling its pop front function. This function gives us the order back, which allows us to assign a temporary variable. But complete current. Alright, no. But complete current order variable first order equals waiting orders dot pop front. We then append the order to our completed orders array. And complete orders that orders dot append first order. We call arrays like waiting orders a queue. The first element we append to the array is the first one we remove. What does, okay, that's just the, let's see in the code, it means just go. Use that to write down code examples and make them easier to learn from. No, but alright. Oh, it's just that's okay. Using arrays as stacks. Another call use of arrays is stacks of data. Big factory management game where you need to retrieve materials from stacks of crates that arrive at the factory. piled up vertically, you need to take them from top to bottom. Okay. Take a crate from the back of the array. The pop back array function. This function removes pops the last value from the array and returns it to you. Here we pop the last value of the array and print what's left of the array to demonstrate how the array gets smaller. I get what it's doing. Like pop front, the function returns the value removed from the array. You will often store that value in a variable. The question could be the crate's content, which you can use to give resources to the player. While parentheses, you will use the append, pop front, pop back array functions. Alrighty, let's do this thing. The waiting orders array will be filled over time. Your job is to move orders from the waiting list to the completed order list using the array's append and pop front functions. Remember that the array's pop front function returns the pop value, does you store it in a variable, and then pass it to another function. Okay, complete orders. So the orders top and that's the syntax of this work again. Pending orders dot pop front wait, how about And then I do waiting. Completed orders. Okay. Waiting for orders. Maybe? I don't know if this is gonna work at all. I doubt it. Okay, so done. Order. Okay. Just give me the fucking solution. What am I doing wrong here? Okay, first of all, I'm not gonna look at that anymore. Apparently I have to not have this. Try again. Why is this blank like that? What the fuck? Oh no, it's not. It's just moving down to this one. Okay. Oh, yeah, here's this. So there, done, order, equals, fuck, I was right, for the most part. I just didn't need all this stuff at the start for some reason. I thought it needed me to add stuff to the list before I did this. What? There you go. So I guess this is automatic and I just need to do the completed segment. Alright, let's look at this again. Complete current order. Guess that's all I needed to do. Yeah, it says the waiting orders we fulfilled over time. Okay. Move orders from the waiting list to the completed orders. I didn't read that properly. That was my fault. Once. Here's the pot value, which allows you to store asset to another function. Oh boy, I need to read this stuff a bit better. Okay, crates are piling up. This is by chance sorting myself. Crates are piling up on the platform. Move them out of the way and popping them from the crates array. Okay. We are move them from the top to bottom using the array's pop back function. The code should remove all the crates in the array while using the while loop. Careful, if you run a while loop carelessly, you can lock the software. You can check if the crates array still contains by running while crates. Yeah. Whoa. What the hell did I hit? Insert? I don't know what that was. Just gonna do this first. I think it's while something in crates, but I'm not gonna fuck with it yet. That might possibly work. Crates. Pop. That's not gonna work. Okay, I can only use that in for loop. Okay. Do a sort of like gonna do something a little advanced. I think I know of. Okay. I hate those fucking errors. They're fucking nuts. Tell me anything. Hit time. No, I don't. Yeah, what's the solution here? The fuck? Oh, I just... Forgot the parentheses. That's all I forgot. I just forgot the fucking parentheses. Ah. Okay. Well, whatever. That's the way it goes, suppose. We're almost there. Oh boy. I'm going to loop over all base. If I stop getting stuck on these, we'd be done today already. I think we could do it. I think we can still pull it off. To loop over all the values in an array using the for keyword. So where did we start at? Those little while loops, I think. We'll be done before the day's over, I think. Possibly, maybe. We'll see. Learn to loop over all the values in an array using the for keyword for value in array, print value. But if you need to access the third item in the player's inventory, the 10th item, there's a dedicated notation to access one element in an array by index. To do so, use square brackets with a number inside the brackets. Index 0 is the first element in the array. So if I wanted the shield to be 2, right? Index 1 is the second element in the array, and so on. You would access the fourth element in the inventory array like so. Yeah. Excuse me. How would you like to? Would you access the third element in the inventory array? 2. You're right, indices start at 0, so the index of the third item is 2. That's why you need to write inventory 2. Accessing the last values with negative indices. We want to access the last or second before last item in the inventory. In that case, you can use negative indices. If you write -1 in the brackets, you will get the last item in the array. You will, for the second to last item, write -2. That's very convenient when you need to quickly access elements from the end of the list. I realize these were runnable. So let's see. Yeah. Shield. -2 would be part. Yeah. How would you access the third to last item in the inventory array? Right. When using negative indices, -1 means the last element in the array. And this index -2 would say the last. This negative would be the third to last. It can be a little confusing as it seems to work differently from positive indices. However, it's because there's no difference between 0 and -0. Both point to the last item in the array. You can't access non-existent indices. Because there's no... Okay. You can't access non-existent indices. They capture the syntax. If you try to access an index that does not exist, you will get an error. You have to be careful always to access existing elements in the array. There's simple ways you can check for valid indices. One of them is checking the array size. Checking the size of the array. Arrays come with a member function named size. You can call it on the array anytime to show its current size. Inventory equals short shield, Current inventory size. This should be full. Yeah. The maximum index you can access in an array is array size minus 1. The last item in the array. Okay, so function run last item index equals inventory dot size minus 1 use item inventory last item index. The sword. And the following practices you will use what else we got? Trying to think. Oh, it does not list 6 then. Wouldn't that be 6 minus 1? I guess you're subtracting from. I don't fucking know. We'll figure it out later. Just like we do a lot of this stuff. All practices, you will use array indices to realign train tracks and grab the correct item in an inventory. In our game, the player has an inventory that works as an array under the hood. The player knows they have a sword and a shield somewhere in their inventory, but they don't remember exactly where. You can see the inventory drawn on the right, along with the index of each item in the inventory. Your task is to find one sword, one shield in the array using their index. Then call use item on each of them so the player can equip those items. For example, if the first item in the array is what you need, you would call use item inventory 0. Okay. What if I do this? Zero, 6, 10, 11. What? Oh, one sword, one shield. Okay, but why is it getting uppity when I do more than just that? Yeah, what the fuck? Okay. Inventory. That was not the right one. Nope. Nope. There we go. Okay. Just trying to teach you this concept. I'm not just doing anything too fancy, but I think I may have also been fucking up the syntax of how this works. So I'm going to just do what it says, and I'm just going to do this. Bam. Fuck yeah. Okay. We have train tracks broken down into little chunks in our game. We use them to make modular tracks and draw circuits of all shapes and sizes. However, several chunks are misaligned. You need to find them in the tracks array and pass them to the align function. Okay. To do so, you need to access the array by index. This time, though, you need to access them with the negative indices. Okay. Okay. Align track. -1, 2, 3, and 4. Okay. Run it. Okay, apparently third one's fine. Or the second one, I guess. There we go, baby. Oh yeah. In the last lesson we used an array to represent a player's inventory, which is an array of items, item names. Last lesson we used an array to represent a player's inventory, which is an array of item names, though we can't easily keep track of the amount of each item. Instead, we can bundle the items, names, and amounts into a single dictionary. A dictionary is a data structure that allows you to map pairs of values. In the pair, we call the first value a key, as we use it to access the second. In other words, a dictionary has a list of keys, and each key points to a value. To define a dictionary, we use curly brackets, so I kept accidentally fucking hidden. The colon separates each key and its value. A comma separates each key and pair value. Colon and a comma, okay. Dictionaries can hold any values. Dictionaries can map about any value to any other value. For example, we can use the name of an item as a key and the amount as the corresponding value. This makes dictionaries excellent for keeping track of a player's inventory. Where we matched the name, a string, to the amount, a number, but a key could be a string, a number, or even a vector. Okay. Not to a number, but a key could be a string and number. Okay. Although we can have all of these different keys, keep in mind that every key has to be unique. This means we couldn't have a dictionary like the following. 5. 8. Duplicate key found in dictionary, literal. Okay, so the string is the same, I said. In the above example, which key would cause the error? Healing heart. The key healing heart appears twice in the dictionary. The above example, though, wouldn't know whether to return 3 or 8 because using inventory healing part. This is why keys need to be unique. The hood dictionaries are also called mappings or associative arrays. Under the hood, they use arrays in several functions to efficiently store or retrieve values across arrays. Precisely, dictionaries use a hashtag algorithm. Hashing algorithms convert one value into another. A hashing algorithm. Okay, in this case, hashing consists of converting a given key into a unique whole number. Dictionary then uses that number as an array's index. That's how dictionary works. When you give it a key, it converts it into a unique index, uses that index to retrieve the corresponding value in the computer's memory. That's also why you can't have the same key twice. It'll map to the same array index, causing you to overwrite an existing value. Accessing values. We access the value of keys by writing the dictionary name with the key in between square brackets. Variable inventory. How would you access how many gems the player has? Item count. Well, there's no. Oh, I guess that's. Okay, yeah, variable. Okay, I'm making a variable in that instance. I was gonna say there is no item count in the fucking thing, but I'm making it there. Okay. Inventory. Gem. What the fuck's the difference between these two? Oh, gem versus gems. Slightly spelled different, so to fuck me over, fuck you. You're right. Make sure the key is the same as we defined in the dictionary. In our case, item count equals inventory gems is correct. So, changing values. We can also change values directly, which is useful in our case for adding or removing items from the player's inventory. Function run inventory healing heart plus an equal 1. So that just increases that by 1. Yeah. We did it. The following practices will use a dictionary for a player inventory and create a function to change the values of items. Oh boy. This is gonna be fun. But we need a good way to store them. Let's give some items to the player. We use a dictionary for the player's inventory. We define the inventory variable for you, but it contains no items yet. Give the player the following items by adding the correct keys and values to the dictionary. 3 healing hearts, 9 gems, 1 sword. Okay, let's do this. Let's do healing. Wait, no, I can do a space at this. It's just a string. Gems. Oh, that's gems. Sword. Key should be text strings and whole numbers. Three, 9, 1. Huh. What? Oh, I needed commas. Okay. That's why I was confused. So it's comma after each of them. Alright. There's nowhere. I did not realize this. Yeah. How did they write these actually? Okay, it's that space then. Okay. I didn't know they had a space between. I actually do there. Not for these. They probably even messed up on that one. Comma. Comma. We did it. Alright. We want to change the item counts in the player's inventory whenever the player picks up or uses an item. We started the add item function for you. Inventory dictionary should use the item name parameters as the key to access its value. Right now, it's test apparatus will increase the item. Okay, so what the fuck am I supposed to do? Hold on. What? Want to change the? I'm gonna go back. I don't remember how this is called. Can you call this? Okay, so you just use the, okay. So I do inventory item name plus and equal to amount. Not item name, item name. Hey. Okay, we did it. My noggin's itchy. Alright, okay. That was easy. I just needed to refresh on how to do that. Alright. We're almost there, aren't we? Yeah, just this and two more. We'll continue streaming at least until we do this. In the arrays, you can loop over dictionaries. Let me fix my earbud that came out when I was itching my head. There we go. Like for the arrays, you can loop over dictionaries. You can loop over both their keys and values. Let's see how it works with two examples. Displaying inventory's content to display the player's inventory. You didn't know what it contains. You need the name and the amount of each object. And from code, you can only achieve that by looping over the whole dictionary and processing key value pairs one by one. To get the list of keys in the dictionary, you can call its key member function. What's a member function? Member functions are functions attached to a specific value type. Like arrays, strings, or dictionaries. We also call them methods. For example, arrays have number functions like array.append. You can also call a function on an array using the access operator dot to access it as shown above. Okay. Variable inventory, you can have 3, James 5, sort of 1, function run, for item name, and inventory.keys, print item name. So this is getting assigned what is in this, so just gonna print all 3 names. Yep, Jim sorts. But it's something we do so much that you don't need to call the function. Instead, you can directly type in the variable name a for loop after the n word. The n keyword, my mistake. The language. The language understands that you implicitly want to loop over the dictionary's keys. Run for item name and inventory. Right, item name. Okay, so I don't need to use that key thing. You can get the values with the syntax dictionary key as you learned in the previous lesson. So like whatever no dictionary is, then dot key. We can loop over the inventory's keys, get the corresponding values, and display all that information in the user interface. Run for item name and inventory. Variable item count equals inventory item name. So inventory is the list or the dictionary. Print the item name from the inventory plus string item count. So it converts the numerical value into a string. So it's gonna do item name colon space number. Yep. Hell yeah. Instead of printing the key value pairs to the output console, we can code and call a dedicated function that displays items in the user interface. Printing the key. Okay, sorry. Instead of printing the pairs to the output console, we can code and call a dedicated function that displays items in the user interface. Function run for item name and inventory. Let's see. Count equals name. Yeah, add item name, item count. Okay. So it makes a new item with a new number. You can also use a dictionary to map units to their position on a game board. So you typically code a board game in grid-based RPG or a tactical RPG. While we focused on string keys so far, these script dictionaries accept any value types as a key, allowing you to map anything to anything. The limitation is that every key must be unique. Okay. Using a for loop, you can use the key value pairs to place units on the board at the start of the game. run for cell and unit cells. Unit equals unit cell cell. Cell value and unit cells. Dictionary. Add units. Unit cell. For this, you will loop over dictionaries and process their content. This one, I don't even have a thing we can do with this. No run, no nothing. Oh boy. We use a dictionary to represent the player's inventory in this game. The dictionary keys are the name of items, and they map to the number of items that the player owns. You do loop over the dictionary and display the name and amount of every item in the inventory. You need to loop over the dictionary and display the name and amount of every item in the inventory. To do so, follow a display item function. It takes two arguments, the item name and the amount. Okay. Or this and play display item right to inventory things. What if I do this? Oh yeah, that's right. And wait, what? No, hold on. No, that's not right. I should keep the right values. I was doing that as a test. Why does I do this? Not yes, this. Alright. And nothing happens. Oh, okay, I get it. What if I did, item name is equal to, no, equal to inventory Okay. This is what happens. I did define it the correct. Oh. Okay. Just this. Oh, item name. Okay, so how do I pull specifically the name and specifically the number from this? Just give me the solution. I don't remember how to do this. Or I know what I need to do, but I don't know what the actual thing I need to write out is. Solution. Inventory. Amount is equal to inventory item. Items doesn't even look like a real world anymore, dude. So for item inventory, item pulls this part. What is making another variable called amount change what it's outputting? Can I just do item twice or inventory item twice? Well, I guess I mean like if I were to do this and put amount. Oh, let me copy and paste this. See. Okay. Item and inventory. The fuck happens if I do this? Nothing. Yet if I do item, it works properly, I guess. Okay, so why would this be different from this if we're equating amount to that? I have no fucking idea. So variable amount equals inventory item. For pulling inventory item, it should be the same as amount then. But they're not. They're registering as two separate things. What the fuck do you mean? I don't know. We're going to have to continue on. I don't know what to do with that one. Alright, we have a dictionary named units that maps a cell position on the grid to a unit to put there using a for loop and the place unit function. Place every unit in the units dictionary at the desired position on the game board. Okay. So, oh, holy shit. Hey, thank you for letting me know. I need to actually message you back later about that. I didn't even know you messaged me. You messaged me like... I don't know when that was actually. That is not my time. Unless if you messaged me like literally over an hour ago. In which case, holy shit. We're almost done here though. We're almost done. We had 2 more of these assignments and we're done. Picture units. Units that maps a cell position. I'm happy that my mic's working though. Thank you for letting me know about that actually. Okay. Let's try what we did last time with that weird thing. Perfect. In units. Okay. Super. The solution is what the fuck? Ah yes, the fabled cell it's bringing back. I fucking hate that thing so much. Oh my gosh, you have no idea. It's so fucking annoying. Oh wait, how about this? Still no fucking idea how that works. Holy shit. Alright, yes. What if I do it the other way around? No, not the other way around, but definitely this way around. Okay. Victor, super. Yeah, no, I'm lost. Completely lost on that one. Alright, let's do this one. Yeah, this doesn't continue on until the end. We're gonna get it eventually. We're gonna figure out what's going on. Some bullshit. Yeah, I think I figured out that cell, the one I keep freaking about, is just a placeholder thing, so not like it's much of a thing. Problem. Let's see, in your code for these particular type, you have already learned about several whole number, decimal number, strings, 2D vectors, arrays, dictionaries. I should type it. Oh, okay, I kind of learned about decimal numbers a little bit. The computer uses the type of a value to know which operation and function you can use that with them. As a result, it's essential to understand types. They are not fully compatible with one another, and misusing them will cause errors. You want to display the player's health in the interface. Your code tracks health as a whole number, a value of type int, short for integer. However, display it on the player's screen, the computer wants text. It needs its value of type string. You can concatenate two strings with the plus operator. Concatenate. I don't know what the fuck that is. Anyways, function run, print hello plus there. Yeah, that's prints hello there. Yeah. Okay. So the following code looks like it would work at first glance. Also, but when running the code, we get a strange error. Invalid operands, string and int and operator plus. Tells you. It tells you can't add values. Okay, I see what's saying. Tells you can't add values of type string and integer. They're incompatible. In that case, you need to convert the health number into a string. Yeah. Convert values into strings. You can get the text representation. You get the text representation of a value by calling the string function, short for string. Str function, short for string. Functions return as argument as a new string. You can use this function whenever you want to turn some number or vector into text. Okay. My health plus string health. Okay. In this case, it turns number 100 into the string 100 or whatever number health it's currently. Converting strings into numbers. You can also convert strings into whole numbers or decimal numbers using respectively the int and float functions. Those functions convert what the player writes in a text field into a number. For example, the number of potions to sell at once in the shop. Variable player put 10 as a whole number and player put. Okay. It just converts the word 10 into an actual number. Or the typed out 10 into an actual number that can be used. Most types are incompatible. You really can't directly add or multiply an array with a number. However, some types are partially compatible. For example, you can multiply or divide a vector by a number. So that'd be, I'd go from 1, 1 to 10, 10, I believe. Yep. Alright. It's possible because other developers define the operation for you under the hood. However, you cannot directly add or subtract numbers to a vector. You'll get an error. That's why in earlier lessons you had to access the subvariables of position to add numbers to them. Take the following division, 3 divided by 2, what result would you expect to get? 1.5? This is right, this is where things start getting fucky. Well, for a computer, there's a little 3 divided by 2 is 1. Wait, what? Oh, I thought I was going to talk about how floats get a little fucky. That's because for a computer, the division of two whole numbers should always result in a whole number. When you divide decimal numbers instead, you will get a decimal number as a result. 1.5. Even if it's just a 0, Adding a decimal place tells the computer we want decimal numbers. This shows you how mindful you need to be with types, otherwise you will get unexpected results. It can get pretty serious. Number errors can lead to bugs like controls not working as intended or charging the wrong price to a player or to players. Understanding and mastering types is a key skill for developers. Beginners often struggle due to the lack of understanding of types. Languages like GDScript hide the types from you by default. As a result, if you don't understand that some are compatible, you can get stuck when facing type-related errors. You'll want to keep that in mind in your learning journey. When writing code, you will need to understand everything that's happening. That said, let's practice some type conversions. Okay. I don't know how that sounds comparatively. Probably turned it down too much, I don't know. I don't know, I'll figure it out later. Well, it sounded good in recordings at least, but I don't know. Maybe me moving around doesn't help things much. That said, let's practice some type conversions. Alright, fuck yeah. Now these I understand. These are a bit better. We want to display the player's energy in the user interface. I swear, the fucking music overpowered my voice this entire time. I would be so upset. We want to display the player's energy in the user interface. Currently, our code has a type error. We're trying to display a whole number, while the display energy function expects a string. The string function. So if I do this, I'll read to the end before I commit to this. Using the string function, clear the type error and make the energy amount display on the interface. We change the energy variable definition. Setting it from 80 would break the rest of the game's code. You must convert the value when calling display energy. Yay, we did it. Okay, so I can do it inside those little boxes. Ready? Let's see here. Send. Yep. Alright, in our game's shops, we want to let the player type numbers to select the number of items you want to buy or sell. In our game shops. Oh, I'm trying to think. Oh yeah. We need to know the number of items as an integer, but the computer reads the player's input as a string. Your task is to convert the player's input into numbers for the shop's code to work. Using the int function, convert the player's input into a whole number and store the result in the item count variable. Okay. Input. Oh, hold on. It's item count. Fuck. Okay. Clear input. What the fuck on? Oh, hold on. I'm at item count. Count equal to. What where am I supposed to do this in? I need to know. Oh. This is a return to integer, not a string. It's already returning as a string. So the player input is... There you go. That's the reason I was confused. It's like, what the fuck is the order here? Are they inputting a string or are they inputting a variable? Of course they're inputting a variable. I mean, a string. They are inputting a string. We need to output an integer. Okay. So here, let's just... So... It's equal to get player input. Okay, so get the player's input from that there. And the item count is the player's input converted into an integer and it's returned to that count. Okay. That makes sense because I was trying to return a variable to this that was already a... Well, actually I could have changed that into a string, but it was just not outputting the correct thing I need to do. So I don't think it would have had a type error. Like if I erased this, ran this, it wouldn't. Okay. Yeah, the only errors it's throwing me is ones that are related to the checks. It's not like an actual like error in the code. Like this actually works. It just doesn't do the right thing. Let's continue. Alright, everybody. Last lesson. And then tomorrow we're going to move on to the real deal. Maybe learn a little bit what I'm thinking about learning tomorrow. Looking over there. What I'm thinking about learning tomorrow is some 3D modeling. I think that'd be good. Probably gotta fiddle around in the actual video game engine. I think that'd be good. That's what I'm planning on doing tomorrow. So, all right, here we go. By default, GDScript is what we call a dynamically typed language. That means that you can just write variables, assign them a value with a number, and assign them another value with a different type. Unlike in some other languages in GDScript, the following code is valid. Run variable health. Yeah, this is exactly what I was talking about. Let's go print out subtext. Yeah, so if I do it step by step, 100 add subtext. Now let's okay. Feature often causes problems down the line. Let's take one example. Exactly what I was talking about earlier in the previous problem. Games use grids all the time, be it for grid-based gameplay or to make algorithms faster. When working with grids, you need to convert grid coordinates into positions in the game world all the time. To do so, you give each cell a size in pixels. You'll likely pick one of two types for that. Float and vector 2. Because pixel positions on the screen use vector 2 coordinates. Either of these two values would be fine. And two types. What the fuck am I doing? My brain is like shutting off. Now it's not the time for this. When working with grids, you need to give grid coordinates and positions in the game. Well, time to do so, you give each cell a size in pixels. You'll likely find one of two types for that, float or vector 2, because pixel positions on the screen use vector 2 coordinates. Either of these two values should be fine. Cell size equals 50. Cell size equals vector 2, 50, 50. Okay. The vector 2 could simplify some calculations, for example, when converting grid coordinates to game world coordinates. Cell size equals vector 2, 50, 50. Function, grid to world cell. Return cell. Okay, yeah, that's what we learned earlier. Example, because both cell and cell size are vector 2 values, we can add them. However, if cell size is a float, we will get a type error. Cell and cell size are vector 2. Anyways. Yeah, so if the cell and cell size are vector 2 values, we can add them. Okay, so yeah, cell size vector 2, 50, 50. Well, the cell. Yeah, okay. I'll just say yeah, move on. However, if cell size is a float, we will get type error. Okay. 2.0. Operator worse due to dynamic typing. We won't get an error right away. We will only get the error when calling grid to world vector 2 1 1, and that's a big problem. Because we're learning, we only have small code examples in this course, but your game's code will get long and split into many files. When coding, you often forget about the code you wrote several weeks ago. And with a lot of code, it could take hours of play before players trigger a type error in your code using type hints. Fortunately, GDScript has optional type hints. Type hints let the computer know the value type you want for variables and report errors before running the code. To specify the type a variable can accept, you can write a colon and a type after the name when defining a new variable. Variable name, type, value. You could tell the computer you want cell size only to accept vector 2 values like so. Will cell size vector 2, vector 2. If you try to replace the cell size with a value of another type later, the computer will not let you. It's 50. Parser error, the assigned value type float doesn't match the variable's type vector 2. Let the computer figure it out. GD comes with a feature called type inference in many cases, but not all. The computer can figure out the type of variable for you. To do so, you write bam equal without the type. The computer will set the type using the by after the equal sign. We could make cell size a variable or type vector 2 like so. We could make a type vector 2 like so. This takes a little typing. You get the benefits of using type hints, like the computer reporting errors better and faster. Why bother to add hints? When you give the language hints like this, it'll prevent major type errors. When you work in Godot, you will see that the computer can report issues as you write the code. It makes the benefit even greater. Type hints can also help improve the readability of your code. It can help you put more information directly in the code. As we saw, types are essential when coding. As we saw, types are essential when coding. When using type hints, the computer will add them to the engine's built-in code documentation system. There's an incredible third benefit for you. By using type hints, you'll learn types much faster. It's excellent for learning. The following practices, you will write the correct type hints to make the code error-free. Our variables get the correct values, but not the right hints. Using the type fu, the type foo, using your type foo. So fucking stupid. Add the correct type names in the variable definitions. No, you cannot use. Oh, you need to write the type name beside the colon and the equal sign. No, you cannot use type inference. This practice, you need to write the type name in full. I don't know if I'm doing this right. Go. Nope. I don't know. Okay, let's go back to this. Okay, I get it. Why is this not working? Oh, okay, I just need to fix this. Okay, I get it now. Oh, it's really confusing for a second. Sure. Oops. Oh yeah. Okay. Yeah. I was like, why is this not working? That was the simplest fucking thing I could have done. Alright, fellas, last one. Holy shit. Okay. Whole number, integer, hello world. It's the other way around in this practice. The type hints are fine, but the values are not. We test to fix the values after the equal sign, so they match the type hint of each variable. So fucking 5. World. Classic. Stable in these sort of things. Two. One. Float. 0.5. You know what? No, I'm getting fancy with it. 5.5. Let's fucking go. Hell yeah. Oh my gosh, we fucking did it. Oh, baby. Alright, yay, we made it. Alright, everybody, fuck yeah. Alright, good job, everybody. Crappies all around. Crappies all around. Crappies all around. Alright, so that's done and dusted out of the way. I'm going to tomorrow learn some either 3D programming or just fuck around in the Godot engine and see what I can figure out. Well, those two, well, maybe both. I don't know. We'll see. We'll see what catches my fancy tomorrow. Feel like we got more boring stuff out of the way, possibly. Probably not. That was a little fun. I enjoyed that. You know, but me reading for 3 hours straight doesn't make for great content, I'll admit. Be fucking around and pulling my hair out because I can't figure stuff out, and that's a little more entertaining. So, we'll see how it goes. See what happens tomorrow. Thank you guys all for watching me. I'll see you again tomorrow, like I said before. And, yeah. Have a wonderful night. Good night, everybody.